Here we go. Cool.
Okay.
Here, I'll take over. Oh, we can share simultaneously. That's interesting. Cool.
Let me shut down some stuff here so I can reserve my connection just to this webinar. Exit. 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 And that's it. Okay, so I don't have anything
No, just your
that mess
desktop.
up with some message or something like that during the presentation.
Oh yeah, yeah, that happens a lot in the guys. I often have to mask out little notifications for video games and things that'll be on Herman or Raphael, or they just have their notifications on.
Yeah.
People are chatting them. Yeah, you can. I'll take the screen share, or I guess let me see. Cool. All right, 10 o'clock. I will let. Can you see my screen, Luca? Does it repeat? Oh, yeah, cool. All right. We'll let them in. Welcome, everybody. We're going to give it a couple minutes. Hi, my name is Alex. I'm with SimSystem, and I've got Luca with me as well. We'll let a few more people trickle in. And Luca just dropped off even and came back in, but we'll start in just a few minutes here. Typically, we've had these webinars, and within the first 5 to 10 minutes, people will pop in throughout those first few minutes. So I'll start and just kind of get us going. I can give you a little bit of the lay of the land here today and introduce you to SimSystem. And then by the time we're done with that, about 5 minutes here, Luca will be ready to get into our main topic for today. But I just want to welcome you. Hi, my name's Alex. Like I said, I'm the Director of Marketing in the Americas office. So I'm here near Louisville, Kentucky in the United States at my house actually today. Usually I'm in the office. But this is my house, and happy to be here today with Luca, who is our speaker for today's presentation. So today's presentation is plug and play 3D printing, simplified CAM workflow for additive manufacturing. So Luca is our product manager in Italy. Luca, you're in Milan, is that right? Or are you in Padova?
Yeah, correct. Milan.
Milan. So he's in Milan, heading up our product management for Paramus, an additive 3D printing slicing software. Paramus is a standalone great solution that he'll show. And it also works with one of our other products, Make and Mill, if you're doing SLM 3D printing and need to refine on your milling machine. So many applications for Paramus, and he'll talk about that today. So we'll get back to Luca in just a second. Before I get too far, I'll introduce us in a second. A few things for just the way today works. I'm going to launch a poll. Actually, I'll do that right now. So if you want to, just while I'm talking here, we have a little poll just to gather a little bit of data. I will launch that 1 second. Okay, you should see that now. And so, yeah, you can just answer a couple questions just about your role. Do you have a 3D printer? Just sometimes that's one of the barriers to entry. How many years of experience do you have? And then while you're joining us today, just be interested in maybe your background or what drew you towards learning about, Paramus or a CAM workflow today. So answer the questions in the poll. A little bit about SimSystem. SimSystem is a dental and industrial software development company. And so we have solutions both in dental, industrial, a wide range of applications. We were founded in Milan, Italy, back in 1999, you can see, and have gone from there to have a lot of global customers. We're an in-house software developer. I always like to highlight that because we can process our own development requests and have a really quick rate of releases. So it's really helpful if you have like if there's a Windows update and there needs to be a bug fix, you can get access to those things very quickly through the reseller network if you've kept up on your annual maintenance. I know in the United States we do where you pay for access for the current calendar year, so you can update as many times if you contact your reseller. And SimSystem does in that calendar year. I'm saying you can update as many times as you'd like to. And we release those every couple of weeks. So, anyways, having access to our in-house team working on those requests, not outsourcing those, is going to speed up how quickly those can be implemented into your production and keep everything safeguarded. So we focus on a lot of our solutions start with automation or auto detection and try to do as much as they can and have a presented clean UI interface that's pretty easy to use. That's one of our main core principles for our software is make it look easy to use, easy to go through the workflow, but to put as much advanced capability into the tools as possible. So I like that we do that. It makes it very automated, very easy to use, but also gives all the capability that you would need for an advanced workflow or any kind of management in the details that you need to do on your nesting. So that's kind of our philosophy. Who we are. We're an in-house developer. Next slide. This just gives you a little bit about where we're located. Like I said, I'm in the USA, and Luca is in Italy today. We've got other great offices. You can get support in your region, which is wonderful. These are our primary dental softwares, Millbox, Make and Mill, and Paramus. Paramus is going to be what we talk about today. That's a 3D printing slicing software, like I said. Make and Mill, already mentioned that. That's a hybrid using Paramus or another 3D printing or software to SLM 3D print a restoration. Then you can see this is specifically printed. These circles are also printed, and then that goes into a special fixture for your milling machine, and then you can refine on your milling machine. Like in this case, you'd refine the internal of the cavity here, the prep. So that's what Make and Mill does. Millbox is our nesting software. Probably people are familiar with Millbox more so. And Millbox is a very, very widely used dental CAM software that allows you to do everything you need to do for nesting management. And it's great because it can bring together all your machines, all your materials. You can do custom everything you need on the strategies or tool sets or anything. So Millbox is a very versatile, powerful CAM software that many, many, many users are using. So Paramus is just another powerful solution in our arsenal. Our industrial solutions, you'll see Paramus appear again here. It has applications in the industrial industry as well as some 3D, which is traditionally Millbox. It's still in Millbox. It's the bones of the structure. And then Millbox is the interface built on top that's more easy to use. Rhino NC is a CAM solution that integrates with Rhinoceros CAD software on the industrial side, integrates well and allows you to do your machining toolpaths there. Just some stats about us. Just have a lot of years in development experience. We got 15 software products. That's always surprising to our dental Millbox people. For some reason, they don't always know that we have a lot of other products. Yeah, a lot of distributors, many licenses sold. Actually, haven't updated these numbers in like a year or two, so it might be higher than this now. Enough about me. Today's presenter is Luca. Luca, like I said, is our product manager for Paramus. He's a mechanical engineer with a lot of experience, 20 plus years, and is a great guy. I got to hang out with him in Chicago last year. Knows a lot about not just Paramus, but all things dental, digital dental, production, CAM, software, that kind of stuff, machining. So yeah, welcome, Luca. Glad to have you.
Thank you, Alex.
I'll check in our
Thank you.
poll, but take it away. Yeah.
Yeah. Thank you, Alex. And first of all, welcome everybody. Good morning or good afternoon, depending on which side of the world you are attending this webinar from. So today I'm gonna show you some simple workflow about Pyramis software, some simple workflow regarding some DLP machines, as well as some laser machines. So what do you say, Alex? Can we start? Can I start?
Yeah, let's start. And I ended the poll here. It looks like we've got people that are primarily either suppliers or lab techs. They've got 3D printers and yeah, a mid-range of experience. That's kind of what I'm seeing. So yeah,
Okay,
it's great.
that's great. That's great. Okay, so first of all, let me share my screen so you can tell me if everything is sharing correctly. you should be able to see my screen now.
Yeah, we can see it. And I
Okay,
apologize
great.
if you couldn't see my screen a moment ago. I got a message, maybe mine wasn't sharing. So apologies if that was the case. But yeah, go ahead, Luca.
Okay, great. Okay, so let's start. This is Pyramis. Okay, for those of you who are not familiar with the software or with Sim System software in general, Pyramis, first of all, is a software dedicated to additive manufacturing only. So with Pyramis, we are able to make a preparation for additive manufacturing process. Pyramis by himself can manage different printing technologies. So it can manage basically DLP or LCD technology, so all of those technologies that works with liquid resins, laser technologies for metal or also for polymers resins. It can manage as well some technology regarding polymer jet, so with some specific machine, and as well with FDM technology. Today we are gonna see something regarding DLP and laser technologies. The user interface, as you can see here, is very simple. So the first time you open the software, you see something like this, that is basically on the right side of the screen, you see few icons that are the main icons that will guide you through the workflow of the software, while on the left side of the screen, you will see some accessories icons like views management, projects management, access to a few tools, access to the configurations of the software, and some undo and redo button. Okay, so now let's start with some simple workflow. As a first step, when we open the software, we start by creating a new job by clicking the first icon on the top right side of the screen. So we click here. Whenever we click here, we have the possibility to change the file name of the current project. By default, the software proposes you a default name that is basically the current date and the daytime, and eventually also to modify the default path where the project file is saved. Then we click on OK to move on, and then we can select the machine we want to work with. Depending on the machine we are selecting, of course, the plate, the platform shown here change according to that. So, of course, there will be a lot of different machine configurations, and depending on that, the what we see here change according to that. Now, I'm going to start with some DLP demonstrations, so some DLP sample machine. Once we have selected the machine, then we can select the material that we want to prepare the job for. So we select material as well, and then we can jump to the next step. So now let me move out this. Okay, next step is where we import the files that we want to work with. Pyramis can by default read STL files as well as 3MF files, so basically the digital mesh files. And here we can import the files that we want to print. Okay, when we import the files, we have a few options. So now I can import my file. The software during this phase completely analyze the file in order to make sure that the mesh doesn't have any problem or any faulty triangle or any hole, anything like that. And in case it finds something wrong, it proposes automatically a mesh fix to the file. Then can import something else just to show. Whenever I select a file here, I have a preview here of the file that I'm importing, and whenever I click on this preview here, I can have also a dynamic preview here that permit me to move the part around and look at it a little bit better. So I can import my part. When I import my part, I can have few options. For example, flip automatically the part upside down, keep the original coordinates of the file that I'm importing, apply a scale to the part imported, and also some automated feature that I'm gonna show you
later on with the presentation regarding the SLM procedure. So now I'm going to import this file. And here it is. The next step is the automatic nesting. So basically in this step, what we do is that the software with the help of a dedicated algorithm is gonna prepare or is gonna organize the parts in the working area in the best way possible according to the parameters that we have set here. How it works? Basically, it works in profiles. So we can set as many profiles as we prefer here with different parameters. And we can as well here do some modification to the current parameters on the fly. So whatever change we do here is a change that we do only for this project, but the real parameters, so let's say the definitive parameters are stored inside the configurations of the software. Now I can select one parameter from here, one profile, and then I can click on this button in order to make the software apply the nesting algorithm. Okay, so back just 1 minute. So basically the parameters that I can modify here are the distance that the objects has to maintain themselves, the distance that the objects has to maintain from the border of the platform. These custom coordinates permit me to define which part of the platform to start with the nesting. Okay, this platform is particularly small, but assuming that we have a very big platform, we can decide, for example, to start from the center, from one side, from one corner, and so on. Then we have also the possibility to modify the distance that the parts has to maintain from the platform, and eventually also do some other modifications. So I can click on each part here on my platform. Whenever I click on one part, I have here some additional information that I can work with. For example, volume of the part, possibility to copy the part, to scale the part directly on the platform. Have some information on the analysis of the mesh. In this case, the analysis, the mesh is good, so it presents just one single mesh, one cluster, and no holes. Possibility to do some movement or some rotation with some predefined or defined value. And eventually, for example, for this part, I can move it down to make it touch the platform, to put it in contact with the platform. I can eventually also generate labels on the parts and base as well. But everything that I'm mentioning here, especially labels and bases, are also generated eventually automatically during the generation of the supports. Okay, once I placed my parts in place, the next step is the generation of the supports. Okay, supports works as well in profiles. So here we have the possibility to generate a list of different profile settings with different shape of supports, different density, different ways of being applied to the single part. So for example, now I select this first profile here, and I click on this button to automatically generate supports for the parts that I have in my platform. Okay, now, because this super profile has included also generation of the base is generated also in this part, but I can in any case select the part and disable the base, or eventually try to support it with a different super profile that doesn't include the generation of the base in order to remove it. And because of this part is in direct contact with the surface, so with the platform, it doesn't have any support unless there is some part of the geometry that require to be supported. But in this case, but this is not the case for this kind of object. And as I said before, we have also the possibility to generate labels. The labels can be generated automatically during the generation of the supports, or they can be generated, let's say, on the fly directly from this tab here. So whenever I click on one object, this contextual menu appears, and here I have the possibility to select the type of label I want for the type of object. I can set different parameters in order to adjust the result. So, okay, let's generate it like this, and then I'm going to adjust the parameters. Okay, so I just created my label. You can see that the label has appeared here, and I can, first of all, I can click on it and I can move it all around my part in the position I prefer. And then I can eventually also adjust some parameter like the thickness, or eventually how much the label or the writings here is going to penetrate into the mesh. I can also eventually adjust what to write inside the label. So basically the label write what is the file name of the part. But I can, for example, write the entire name of the part, or few letters from the beginning of the file name, few letters from the end of the file name, or eventually a unique ID that is basically a number that we associate to every part that we import in our job, starting from 1 to the end, so the number of parts that we have in our job. So when everything is prepared, the last step is the computation of the output file, so the slicing. What I haven't mentioned is that here we have the possibility in any case to move the part. We can adjust the height. Usually, as you can see here, the supports adjust automatically, but eventually there could be the needs to recompute the links. In this case, I can click on this button to recompute the links, because now there is enough height here for a few supports also to have some additional links. And this is it. So the next step, as I said, is the generation of the slicing. So here in the project data field, I can have some recap of the current project. I can also select a slicing parameter here. Depending on the slicing parameter selected, I can have different parameters applied, so exposition time and other parameters that are usually assigned to this kind of technology. And by clicking on this button, the software starts the computation. Okay. At the end of the computation, we can have also an automatic generation of a report. Of course, this is not mandatory, but in this case, I have it enabled, automatically generated at the end of the computation. The label is based on a prototype or a template file that can be adjusted according to the needs of the customer, of course. And it basically recap the number of the parts, the file name, and a few other informations that can be added according to the needs. As well, here is also possible to have a preview of the slicing file. So if we click yes, we can here, we can have a preview of the single slices. So we can browse, moving with the arrow up to move the single slices to see the slicing result. And it can be also
see in 3D. So we can also see as a 3D file which slice and where it does apply. So as you have seen here, the standard process is very simple and straightforward. So within a few commands, you are able to generate a file to be sent to the printer. Now let's enter something a little bit more complex. So I'm going to show you a workflow now regarding SLM technology, so laser melting basically. So I'm going to create a new job now. I'm going to stick with this data. So I say, okay. Next, I'm selecting a specific machine for this process. Here I can as well select from different laser profiles. In this case, I just have one, but you can have multiple, especially if the machine is enabled to work different materials like cobalt chrome, titanium, or other materials. Next step is where we import the files. Now, what's mostly interesting is that we can, for example, import an entire folder. Okay, so now if I click on the folder and I can import everything with this detect function, and now I'm gonna explain a little bit better how it works. I can click on this button to perform an importation of the entire folder. Now the software informs me that the folder contains 96 files. I can click OK, and within a little bit of patience, we can see the final result. Now, during importation, now because I have selected the option detect, the software is completely analyzing each single file, detecting or identifying what kind of parts we are working with. So basically, the software is able to identify the dental parts and identifying few features of the dental parts like margins of crowns, screw channels for implant bridge or single abutments and so on. And we take advantage of this kind of informations for optimizing the orientation of the parts while we import the objects, as well as optimize the positioning of the supports when we are going to generate the supports. Importation is done, and as you can see here, whenever I click on a single part, we can have few information on that single part, but we can have also here some additional information that says that this part has been recognized automatically as an anatomic bridge. So if I click on these other parts, we can see that this has been recognized as an abutment, and let me select single crown, so we can see that this part has been recognized as a crown, and this automatic recognition works in this way. So we recognize the different kind of parts, and we optimize the positioning of the parts according to that. We have also possibility to customize some setting in this regard. Next step, now we have this, let's say, kind of mess, but next step is to do the automatic nesting. So what we do here is that we click on this button and we let the software do the automatic nesting for this specific job or this specific objects. I know for sure that these objects will not fit one single plate, and now you will see what the result will be. So basically, now the software tries to fit as much as possible the plate with the parts, but because there is no space for the parts, the software also informs me and asks me if I want to create another job with the remaining parts. What I say is basically I say yes, and the software automatically generate another project automatically to try to fit the remaining part. And this continues on and on until all the parts are fitted in various jobs. So I can move on, say yes again.
And again, and this should be the last. Let's see if they can fit. Okay, yes, they can. Okay, now basically we have prepared a few platform with all the parts that we have previously imported, and we can go here into the project management and see all the plate that we have generated. Okay, so what I'm doing now is I can load every single plate with, for example, starting with the one that I want to start the printing with, and prepare it for the printing process. So what I'm doing now is that I'm generating supports. So here I select the support profile that I want to use for this specific part. I click on this button to automatically generate the supports. And now the software computes the supports for each single part. As well, in this case, also is generating an ID tag label. So now in few seconds, we should have the final result. Okay, we have done. Okay, now what I usually suggest prior to start the slicing is to check every single part to be sure that everything is fine, especially the positioning of the labels, because the positioning of the labels is not always optimal automatically and needs to be adjusted manually. So for this purpose, we have a specific function that can be found here in the tools, and then we can enter this visibility tool. Here we have two different possibilities. We can click on a single part in order to highlight it singularly without having all the other parts around, or we can eventually enable this box to see the other parts in transparency. If we want to go out from the single selection, we can simply double click out of the plate, or we can simply click on these two arrows to browse every single element I have in my plate. And whenever I click on the single element, I can also, for example, modify the positioning of the label, adjust the positioning of the supports if I want. If I see some supports that I don't particularly like, I can click on it and delete it easily. Then I can move on. I can do this for every single part that I have in my plate just before the start of the slicing process, just to make sure that everything is okay. I can also eventually click on the part and adjust the supports manually. So I can select one single part. I click on this button in order to adjust. Like this, for example, I can click on a part. Selecting. Okay. Click on this in order to, for example, adjust the positioning of the supports of the single part. So I can close it. I can click on this one and do the same. For example, to adjust the positioning of the supports here, I can easily add or delete existing supports, or with these shortcuts, I can, with the A button, goes automatically on add. If I remove the press on A button, it automatically moves back to move, and the same works with delete.
So D and A moves automatically the selection on the related box. And then I have also additional features here that permit me to see the slope of the surfaces, the possibility to see this shading only on bottom areas or on all the parts of my object, possibility to see flat shading or a more smoothed one. Limit points to threshold is basically a function that limit the movement of the points within the threshold that we have identified as a part of the object that needs to be supported. So if I remove this check, I can move it also outside of this area. And I have also possibility to highlight minimum areas and also feature lines in case we have some geometrical parts where we are not so comfortable able to see the depth within different surfaces. At the end, once I adjusted the positioning of my supports, I can simply reselect here the support profile that I want to apply for this specific part. I click on Create Supports and then close the function to exit the function. And this is basically how it works. To conclude, we basically can start the slicing process. Here as well, we have a recap of the current project with the name of the project, the machine selected, and the laser parameter selected. We have here as well the possibility to... Okay. In any case, in the meantime, let me start the other software because I want to show you as well something regarding the integration between our Make and Mill software and Pyramis. So regarding the hybrid process. Okay, so computation must be done. Here is also a final report of the parts of the files in this specific plate with the recap of the file names for each one of them. At the end of the computation is also possible for laser technology to, to see a preview of the slicing. So here we have the possibility to see a preview of the slicing of these specific parts. Okay, maybe I can do it now. And here we have the possibility to move the slider to see each single slice for the specific project. Okay. Now, let me see if I can close this one to save some resources. Okay. Now, what I want to show you is the integration between our Make and Mill software and Pyramis. So basically, whenever we have the possibility to have both of the software installed on the same computer, we have a direct integration with these two softwares. So here I'm loading an existing project of an hybrid hybrid process. So basically, this is a sample with an implant bridge, a few abutments, and a couple of crowns. And what I want to show you is the possibility to directly send the prepared structure to Pyramis. So as I said, whenever you have the two software installed on the same computer, this icon automatically appear. So this icon permits to export the part directly to Pyramis. By clicking here, now the software is starting to generate the files to be sent to Pyramis. Close this one, so it will start a new new one. Now in this phase, the make a mill is creating a single joined mesh of every single part that we have in the job. Okay, we are finally at the import. So now the software has automatically launched the project to Pyramis, and now Pyramis is going to import it correctly. Okay. So here, as you can see, we have the imported parts. So the advantage of this integration is that, as you can see, we have separate parts. So we can manage the parts as separate objects. For example, maintaining the different features that we have for each single part. For example, when we are going to place supports, we can have some advantage that we have the identified screw channels, where we usually try to avoid to place supports inside. And also we can treat the part in different ways. These are the main advantages of having this direct integration between make and mill and Pyramis. Now I can click on this button to start to generate the supports.
Okay, as you can see here, we can have as well labels for each single part because the parts are identified as a single object. And that's it. So basically at this point, what it remains is to start the slicing computation and to send the job for the printing. Okay, so this conclude my basic presentation of the software. So I think I might touch all the topics that I wanted. I don't know, Alex, if there are questions or something from the viewers.
Yeah, thank you, Luca. Yeah, we have no current questions in the chat, so now's a good reminder. If you guys have any questions about anything you saw in the workflow, just about nesting or any of the tools, or whether it applies to just Paramus or Make and Mill as well, go ahead and you can put those questions in the chat now. We can take a few of those if you have any questions. Otherwise, yeah, I think I did have a question here that we had put down to ask you just about what type of printers Paramus works best with. I know there's a lot of different kinds of printers. Obviously, you touched on SLM.
Yeah.
Yeah, what are the applications, I guess, for Paramus, different applications?
Yeah, as I mentioned at the beginning of this presentation, we mainly work with different kind of technology. So we work with DLP or LCD machines. We work as well with laser machines. We work with polymer jet machines, and we work with FDM technologies. What can I say more? Pyramis, I think it works best with all of them. There are few machines that we are not able to manage, but basically because we have no direct information from the manufacturer, or the machine itself is locked to be used only with the software provided by the manufacturer. So these are the eventual limitations that can be.
Yeah, very similar to milling machines. It's
Yeah,
either open or closed system. So we're talking about
exactly.
open system printing, similar to I guess how you would think about milling. There are a lot of printers out there, but what's your software that you're using to nest? We definitely agree that consolidating that into a single slicing software can help you, manage your production a little bit more efficiently. And as Lucas said, he fully believes that the quality of everything we have inside of these slicing softwares is going to work well for your applications in dental. So yeah, it's a great advantage to be able to consolidate some of your production, have an easy to use software for all of your, different printing workflows. It can be different. Am I right to say, Luca, you could have different type printers, but they could both use Paramus, or would there be some?
Yeah,
Yeah,
definitely. Yeah,
that's great. So you
of
could have your
course.
SLM printer, your DLP printer, and you could be running a
Yeah,
Paramus to help
for
manage.
sure.
Yeah, so some great advantages there. Just in general, I know of some specific workflows we have, like he mentioned that, like that Trusana one, or like the inkjet. There's a lot of different applications for Paramus, and Make and Mill is one that definitely compensates for the lack of resolution in SLM printing at the moment. So that way you can save a lot of material if you have an SLM printer or are looking to get one for even other workflows, and you have a milling machine. Definitely look into Make and Mill because you can get greater definition on some of those areas that you can't get through just the raw print by putting that in the milling machine. So, anyways, there's some great applications for you. I'm not seeing any other questions in the chat. So, last chance, anybody, if you'd like to put something in last. But other than that, I think thank you very much, Luca. I'm not seeing anybody put anything.
Yeah.
So, thank you for your time.
Thank you. Thank
Final
you to
words?
you, Alexa. Thank you, everybody, for
Great.
listening at this webinar. And with this occasion, I also like to take advantage and say that we will be present next week at Formnext for the, let's say, the biggest international exhibition in 3D printing. So for anyone who is going to attend it, please step by our booth. We will have a booth there, and it will be a pleasure for me to show everything in person.
Great. Well, thank you, everybody. Thanks for joining. We were happy to have you. I hope to see you in a future webinar. Thank you, Luca. It's been great.
Thank you. Bye.
Bye, everybody. Have a great day.